A very good evening to all. I'm Vijimol. I welcome you all on behalf of Multi-Cloud for You Technologies. Today, the session is about Data is the New Oil by Karthik Konpak. Let us begin with a quick overview of Karthik. He is a big data developer, analyst programmer. Moreover, he is a workshop facilitator, content viewer, trainer in technical writing, and YouTuber. He specialized in Spark, SQL, Hadoop, Hive, MapReduce, Scoop, data structures, and DSA. You can discover more about him from our Fifthaya speaker profile page. So about Fifthaya, Fifthaya stands for Fifth Industrial Revolution. We are initiative by Multicloud for you to help companies and technologies to openly share their learning and get opportunities worldwide through each other's as well as through our partners worldwide. We are expanding with 25,557 members and 359 existing speakers. We have completed 1,068 sessions successfully till now. Moreover, we have issued 8,458 certificates so far. We are maintaining a positive relationship with Data Global, Dell, Brilio, Tiger Analytics, Alibaba Cloud, Data Piper, Philips, Jira, and multiple small and medium companies. We also frequently engage with evangelists and engineers from Microsoft and AWS. We have good partnership with Alibaba Cloud Academy. These are the various certificates we offer as an affiliate with Alibaba Cloud Academy. We are happy to help in building your knowledge, digital presence, and helping you in our tasks when you are looking for jobs through our community. Or you can get it with a single link, that is www.fifthaya.com. How to get the certificates? Once you register with the link, you will be directing to this page. Here you can see download certificate option. Then click on download certificate and provide all the required information. Then you will be asked for a code. Enter the code which will be provided at the end of the session to download the certificate. For any issues, you can contact our Telegram channel, that is telegram.im/multicloud for you. Now the session is over to Karthik.
Myself, Karthik Konpak. I'm working as a big data developer currently at Citibank. I'm also a teacher. I'm a mentor. So I'm as a YouTuber also. So, I started my career as a big data developer from Code.ai. Then I switched to Ramco. Then now currently working as Citibank. So, agenda of this session will be very simple. Like we'll be learning what actually the big data is, more specifically what actually the big data is and why, what's the reason big data and tech stack actually has evolved, and what's the reason behind that. Actually, what are the tools and technologies being used currently in industry, and what are the tools and what are the technologies being currently used to solve the big data problems in the industry. We'll try to understand one by one, and let me share the screen and we'll start the session. I think everyone is able to see my screen, right? Just confirm.
Yes.
Hello.
Yes, it's visible.
Yes, it's visible, Karthik.
Hello.
Yes, it's visible.
Hello.
Am I
Hello.
audible? Yeah, it's visible from your side.
Yeah. Okay. Fine. Thank you. Thank you. Yeah. So the thing is, guys, let's understand what actually the big data is, and agenda is today's agenda is like what actually the big data is, why big data, and history of big data, and we'll try to understand what actually monolithic versus distributed systems are, and we'll try to understand Hadoop, and we'll try to understand what actually the data pipeline is, and we'll try to understand what are the big data tools being used in industry. So in this manner we'll go one by one, guys. So when it comes to big data, guys, so what is actually the big data? The term itself says that So someone says that when volume is so huge, they term it as big data. And some people say that whenever whatever the data which will get, if it is not able to store on our particular laptop, or else let's consider your PC only. If it's not able to store on that laptop, if you're not able to process that, then they say that as big data. So there are multiple definitions, but there should be some proper definition, right? We might get many such definitions when it comes to big data, but we should have some proper definition. So IBM has given some formal definition. It states that what it is stating is like, if whatever the data it might be, if it is characterized by three V's, so we can then IBM said that if any data is characterized by three V's, then we can terminate, or we can say that data particular as big data. So what actually that three V refers to? So IBM said that there is, if any data, like they said that there are three V's: volume, variety, and velocity. So if someone there are some characteristics, if any data possesses these characteristics, then we can consider that data as more specifically big data. So when it comes to volume, what does it that volume refers to? Like more specifically, volume refers to the like the huge more specifically the storage. So now the volume of data should be large. More specifically, the volume of data should be large, and they said that it should be some terabytes to petabytes more specifically. And you can more specifically, you can specifically can say that if our single system or single machine was incapable of handling that, then you can say that there is a huge volume of data. So you can specifically take the example of Facebook only. On every day-to-day basis, Facebook users upload more than 900 million photos a day. Huge volume of data, right? Those kind of that kind of huge data, it is incapable. We can't capable. We don't have that capability to store it on one machine specifically. So traditional systems like us, what are the traditional systems we are currently using, that are not capable of handling that more specifically. So that refers to the volume more specific. When it comes to variety, so now it said that the data which will be getting, actually that data might be of not of one variety. So we know that there are multiple kind of variety of data. Structured data is there, semi-structured data is there, unstructured data is there. When it comes to structured data, you can specifically can understand that it's a RDBMS specific RDBMS kind of data. Like more specifically, you can understand the MySQL database, Oracle, SQL server, like you can understand that. Semi-structured, you can understand that it might be in CSV, XML, JSON format. And unstructured, you can say it has audio, video, image, and log files. Don't consider that the data which will get will be in only in structured format. It's not like like a database management system, more specific RDBMS kind of. And after that, it also said that uh, volume, variety, and velocity. So velocity, there is on a third V is like velocity. What does this velocity mean? The speed at which actually data will be coming, right? We'll be getting data definitely. It might will be getting data in the form of file formats. You might be getting the data in terms of like from RDBMS systems. That the data will get there. So in data pipeline, we'll definitely getting a data, and you are doing some many activities in a data pipeline. So the speed at which actually the data is coming, we actually terminate that as velocity. Velocity. In simple words, you can say that the speed at which the data is coming and speed at which we are ingesting it, processing it, and retrieving it. So that specifically you can consider it as velocity more specifically. So example for that was more specifically like like a Facebook example only. You take that 250 million images may be seen, like you can consider that per day 250 million numbers, more than 250 million numbers of images will be uploaded more specifically. The velocity at which whatever the uploading is being happening, right, that ingestion kind of thing, the speed at which it is being actually uploaded, or whatever the things are happening, you can consider that as more specifically the velocity. So these are the three kinds of V's which actually IBM has quoted, that if any data, whatever the data it might be, if any data has these characteristics: volume, veracity, and velocity. Volume, variety, and velocity. So these three V's, if any data will has these three V's, and if it is relating to that, more specifically if volume is large, and if the data is of these three categories, either of one of the category, like it might be structured, unstructured, and semi-structured. And if the data at which the these things are happening, like the speed at which data is happening, data is coming, all those things is happening, then that particular data we can call it as big data. And it also said IBM also says that there is also one more V, which is more specifically which we can relate it and we can consider it. And it also given a definition for fourth V also. And it said that we can consider that as well. So it says that the fourth V is nothing but veracity. Here the thing is like, see, veracity here is nothing but the quality of data. More specifically, you can understand. Let's consider. I will tell you one thing. So when you are getting some data, when you are ingesting some data, so when you are doing or some performing some activities, definitely here you are doing many activities behind the scenes to get some good insights from that. More specifically, so let's consider you got some data. Let's consider you got some data and consider the data. In the data you might have null. Let's consider a very simple example I will give you. Consider you are getting a data in age column. There is a column called age, and in that you are getting the data. You also know that guys, like age never be negative. So that doesn't have any sense. That negative age doesn't have any sense. That doesn't have any sense. So in that context, actually, what we say is that if that particular data is not giving some meaningful insights, then we call that whereas that data as low veracity data. If it gives some good insights, then we'll consider it as a high veracity data. So in that context, so now you can say that when someone asks you specifically what actually the big data is, so you have to give some proper definition, because like IBM and the industry follow some these kind of, like, more specifically four V's. If any data is characterized in these four V's, then we can consider that this data is big data, more specifically. And moving next to other slide, like there was a common, like this was a very common thing, like why big data. Like we are having multiple systems, right? We are having systems. Why two? A simple thing. So when, let's consider, when you are getting data in terabytes, petabytes, definitely you also know that our max to max our hard disk might be 1 TB. There might be some higher advanced versions where you can find 2 TB kind of systems you might be. So you also know that, like a petabyte means it's more than like 1024 TB is 1 petabyte. So we can't store 1024 TB of data on one system, because we are having a minimum resource of 1 TB. We can store max to max 1 TB of data on our system. So now, but if we are getting large amount of data, we are incapable of storing it. We are incapable of processing it. All this comes under, like, these are the very disadvantages when it comes to data. So in that context, so big data has come into the picture. That what big data is now, big data is something which actually process that large amount of data, which actually our traditional systems can't do, more specifically. So this is what actually the big data is. So let's move to next slide. We'll understand the history of big data. So what actually happened is, so in history, like in early 2000s, like when actually Google was having web search, more specifically, there was Google in early 2000s, Google has a web search. So in what they used to do is, like, they used to maintain it on actually monolithic system. Monolithic system here is nothing but a big system. You can consider that your system only, your one machine. The data will be stored on only one machine and one server. Such systems or such machines will called as monolithic machines or monolithic systems. So in early 2000s, whatever the Google web search was actually there, it was used to be on monolithic systems. Monolithic systems. So what actually happened is, like, they predicted that many people are coming to the web search and data is generating a lot, and they predicted that future might gonna be problem for them. They predicted at that moment only. They predicted at that moment only, and they come up with they just thought that there should be some eradicate there should be some solution for that. And what they did is, like, in 2003 they have come up with a logical, they have just given a theoretical definition. They haven't implemented anything. They have just released a white paper which is nothing but a theoretical definition. What they said, they have said that we can store our data on multiple systems. Why can't we store that data in multiple systems? We can store we can store our data on multiple systems. In that manner, they have given some theoretical definition. So after that, they have given some theoretical definition. That's done. Now they thought that they thought that no, we have given the theoretical definition for how to store the data on multiple systems. But if our system is if our data is present on multiple systems, definitely the languages like Java, the different languages like Python will not work, because these are not traditional languages. They can fetch the data only if your data is present on single system standalone machines. Only if on particular your PC, if your data is there, then you can apply your Python language, your Java language, all those languages you can apply it, and you can fetch the data and you can transform according to yourself, your requirement. But now they said that now they in 2003 they have implemented a white paper really stating that we can store our data on multiple systems. Now storing is fine. They have given a proper definition, proper some theoretical definition that we can store our data on multiple systems. Now storing is fine. How we can fetch that data from multiple systems? So in that context, in 2004, they thought that when our data is present on multiple systems, there should be some computation engine or something which would pick the data from multiple systems and transform our data according to our needs. So in that context, in 2004, they have released one more white paper. And what they did is like, they also at that moment also they said that they have released a white paper, and they have said that they have named it as a MapReduce. And they said that these MapReduce gonna pick the data from multiple systems, and it will transform our data according to our needs. They have not implemented anything. They have just given some theoretical definition at that point. And for this computation engine, they have specifically named it as MapReduce. More specifically, they have mentioned it as MapReduce. When it comes to this storage service, which they have implemented in 2003, for that they have given a name as GFS, Google File System. So after that, guys, no, this has happened. 2003 they have released one white paper. 2004 they have released one paper. In 2003 they have released a white paper in regards to storage. They said that we can store our data on multiple systems, and they named that white paper as GFS, Google File System. And in 2004 they have again come up with a computation engine, and they named it as MapReduce. And they said that this is what actually the strategy is. This computation engine will go on to multiple systems and pick the data and will transform data according to us. And they have given the theoretical definition, and they named it as MapReduce. Now this happened. Now what happened in 2006? In 2006, Yahoo took these two papers. Actually, Yahoo took these two papers, and what they did is like, they have implemented GFS and MapReduce. They have implemented GFS, Google File Systems, and MapReduce. Both of them they have implemented. They have so they have changed. Now what they did is like, now 2000 in 2006 they have implemented MapReduce as well as GFS. And they have changed the name of GFS, Google File System, to Hadoop Distributed File System. And they have changed MapReduce. They didn't change any name. They didn't change any name of this MapReduce. They kept MapReduce as MapReduce only. So this is what actually the first version of Hadoop actually. This is what in 2006 only the Hadoop version 1 was actually came into the picture when they have implemented the thing. You can understand. So this is what actually in terms of Hadoop. Now we'll move forward with big data requirements. Let's consider what does this big data requirement in the sense is like. Now Hadoop when someone want to build some good big data systems. So definitely if someone wants to build some good big data system or big data kind of pipeline, like in that context, it should satisfy three conditions. First of all, first is distributed storage, they should satisfy. And second is it should contain distributed computing service as well. And third one should be, it should be scalable. When we more specifically speak about scaling, there are two things which will come into the picture. One is monolithic, and there is another thing is distributed. Monolithic and distributed systems will come into the picture when we more specifically speak about scaling. So we got to know that before coming, what I'm saying is like in 2006, Yahoo implemented GFS and MapReduce, and it has named it over GFS, named it over HDFS, and MapReduce named it over this thing. And Hadoop version 1 was Hadoop 1.0 version was implemented. That's fine. Now uh, let's consider when at that moment when it was implemented, actually many people don't know about this Hadoop 1.0 version, all those stuff. So now they are also facing the same issues. Many bigger data is coming. No, they don't know about Hadoop, all those stuff. They only know that to build a good big data system, one should, whatever it might be, whether it is Hadoop or some distributed service, other service, Hadoop service or some other service, they have just generically told that if someone want to build some big data requirement, some good big data system, that big data system should consist of distributed storage, distributed computing, and it should be scalable. So in that context, they got to know that Hadoop, they got to know about Hadoop. They like Hadoop is meeting these all those demands. Hadoop is meeting distributed storage, it is having HDFS, Hadoop distributed file system. When it comes to distributed computing, in Hadoop we have distributed computing, which is nothing but a MapReduce. They got MapReduce as well, and these two were like qualifying the conditions, and they were in doubt about scaling of these things, whether if we go with Hadoop, whether it is scalable, not scalable, all those stuff. They were like just thinking of that. Like at that moment, there was two options for them, whether to go with monolithic and distribute, or to go with distributed. All they know that monolithic anyhow in early 2000s, Google's web search was on monolithic. So obviously they don't know that, they know that obviously it won't be like in monolithic we can't increase the storage, we can't store whole day, some petabytes of data we can't store on monolithic system. But they want to analyze those things, or in that context what they did is like they just had a gone through that what's like more specifically, they have gone through what's the difference between monolithic and distributed systems, and they try to understand, does this Hadoop also have that kind of scenario, like all those stuff they want to understand. So in that context we'll try to learn what actually this monolithic and distributed systems are. So monolithic system is nothing but a, more specifically you can understand, it is a single powerful machine. Single powerful machine, you can consider that our machine only, you can consider our machine only, but it's a kind of our machine only, but it's a single powerful machine. So now in that monolithic system, there won't be true scaling won't happen. Actually what actually happens is like, let's consider your system only. Let's consider now your system might have some requirements, some resources. It might be some 4 GB RAM or 8 GB RAM. Let's consider 8 GB RAM. 8 GB RAM is there, some 1 TB of data is there. Now tomorrow today you got a data. Let's consider today you got a data of 1 TB, 1 TB of data you are getting. And now when 1 TB of data is getting, you are able to store your data on your system. That is fine. But let's consider tomorrow you are getting some 2 TB of data, and so at that moment you thought that 2 TB of data I'm getting, right. Let me increase 2 TB of data. You have increased 2 TB of data. Day after tomorrow, let's consider if you got 10 TB of data. Now again if you go with increasing of that 10 TB of if you increase your resource to 10 TB. So now like here the thing is like, what you are doing is like on same system, on same machine, you are increasing the resources, you are not increasing the systems. You are on same system, on same machine, you are increasing the resources, you are increasing the resources. What will happen because of this is like, when you on same systems, when you increase your resources or when you double your resources, what actually happens is like your performance will never increase. That's the reason you will never see a phone or a PC with 100,000 GB of RAM. You will never see any PC or any system that is having 1,000 GB of RAM. If that would be the case, then we would have maintained everything on monolithic systems only. We would have never gone with distributed system. So this is what actually more specifically in regards to monolithic system. And then what does this distributed systems are? The distributed systems are nothing. You might have you might have you have some 10 to 15 same machines. Let's consider you have a 1 TB data and some 8 GB RAM of one machine. Such 10 machines will be there. That 10 machines will come together and will try to solve a problem of you. And more specifically, if you can say, if you are having 1 TB, if you consider you are getting 1 TB of data, consider you are getting 1 TB of data. So at that context, what actually happens is like this 1 TB of data is actually divided into multiple systems. Your data is divided into multiple systems. On multiple systems, your data is stored. This is actually we call as a distributed environment, more specifically distributed systems. So now the data is distributed across multiple systems, and that particular all the distributed systems will come together and will solve your problem. This is what actually distributed kind of environment. In the distributed kind of environment, let's consider you are getting today 1 TB of data. If you are getting 1 TB of data and you are having just two systems to handle that, tomorrow if you got 4 TB of data, in that context, instead of increasing the resources on same systems, what actually we are doing is like what we are doing what we are doing is uh, today we got 1 TB of data, 1 TB of data, and you are having two systems. You are having two systems. Let's consider you are having two systems, and tomorrow you got 4 TB of data. So at that moment, instead of increasing the resources on same systems, we will increase the systems. If we got 4 TB of data, we'll increase our systems to 4 TB. Four systems, 4 TB of data we are getting, then we'll increase our systems to four systems. So in that at that moment, one TB will go to one system, and they can easily manage the work. So this is what actually here, what here in this more specific in distributed environment, what actually happens is like you are not increasing the resources on same systems, you are increasing the systems. So this is the true scaling. More specifically here, when you are increasing the when you are increasing the resources, is you instead of you are getting the double performance here. You are not increasing the resources on same system, instead you are increasing the systems here. So this is what actually the distributed systems or distributed environment is more specific. So now they said that for big data requirements, we every the system or the some service, whatever the service which is solving this big data problem, that service should definitely consist of that should satisfy three conditions. One is it should definitely consist of distributed storage, and it should consist distributed computing, and it should be scalable. And it's in scalable, we got, when it comes to scalable, we also we got to know that distributed environment is very good over monolithic systems. So when these three conditions they catched up, so when they catched up these three conditions, they got to know that Hadoop in at that moment only Hadoop was evolved actually, and Hadoop was able to satisfy all these conditions. Hadoop has HDFS, which is nothing but distributed storage. Hadoop has MapReduce, which is nothing but distributed computing, and HDFS can scale up to whatever extent it might be. Today you got 1 TB of data, tomorrow you are getting some 10 TB of data, it will scale up because it is implemented on distributed environment. It is implemented on distributed environment. That's the reason Hadoop has satisfied all these countries, all these three conditions. So in that at that stage, actually Hadoop came into the picture, and Hadoop evolved as a big data solver. You can say, you can consider big data solver. Now we'll move forward, guys. Now in Hadoop, you have many things. I said that before evolving Hadoop, there was a GFS, which is after in Hadoop version one. Hadoop version one, it was changed the name as Hadoop Distributed File System. Then we have seen MapReduce and Hadoop version one. We have Hadoop version one, Hadoop version two. So what's the difference between Hadoop version one and Hadoop version? Just the simple thing is like in Hadoop version one, actually we used to have only two things. One was like we used to have HDFS, it's a distributed storage, and we used to have MapReduce, and this is computing. So at that moment, what actually used to happen is like there don't used to be a scheduler. Like you can consider that if some jobs are running properly, whether resource manager, you can consider that manager only. we call it as a resource manager. So now MapReduce, what MapReduce used to do is like it used to provide computation service, as well as it used to check everything whether job is working fine, whatever the logics we have written, it is working fine or not, whatever the data pipeline we have built on HDFS and MapReduce, whether it is working fine or not. If it is not working, all those tips. Let's consider if you want some extra resources, like everything, like computation service as well as managing kind of things, both used to be done by MapReduce. But what used to happen is like when it used to do whole things, MapReduce, like a computation service, and it used to look after that managing services also. So at that moment it was becoming so difficult for MapReduce to look after both things, to perform computation service as well, and to provide managing services also. So at that context, what happened is like an Hadoop 2.0, Hadoop 2.0 version, what actually what actually happened is like HDFS was HDFS only, it was same, but this MapReduce were divided into two parts. One is MapReduce and other was converted as, you can, resource manager. More specifically, you can consider it as Yarn resource manager, more specific. So now in 2.0, now MapReduce is divided into two. MapReduce as one computation engine and other as resource manager. It has given they have provided a name called resource manager, which is nothing but you can consider Yarn is currently trending. That's the Yarn resource manager you can consider. So now in Hadoop 2.0, HDFS what only meant for storing the things. MapReduce used to only look after the computation services, and there was a separate resource manager. If you it used to look after everything, whether job is failed, if it is not, whether it is running properly or not, whether it is dead, whether it is not dead. If we need any specific resources, then it used to provide that resources more specifically. So this is what actually used to happen in like MapReduce. Now from Hadoop 1.0 to Hadoop 2.0, and Hadoop 1.1, Hadoop 1.0, only this used to be there, HDFS and MapReduce. But in Hadoop 2.0, we got three things: Hadoop, MapReduce, and resource manager more specifically. Now the dependency, like whatever the things usually it used to be performed in Hadoop 1.0, now it has reduced. And one more extra service has been created, which is nothing but Yarn resource manager, and that used to look after everything in terms of resources, in terms of jobs, all those stuff it used to look after. So this is what actually more specific regarding this. So after that, guys, we'll move forward. So what actually the data pipeline is, guys. So let's consider what actually the data pipeline is the thing. So actually in real time, guys, more specifically, we'll get a data. We'll actually get some data more specifically. And the data, you can say that source we'll get some data from some source. More specifically, you can consider we'll get data from our some source. And what we'll do is like from that data, whatever, let's consider you are received your data, you have got your data in some RDBMS system. Let's consider some RDBMS. More specifically, you can consider as MySQL system. In MySQL database, you are having some data. Let's consider you are having this source is, consider this source as MySQL, and you got your data is presented with MySQL. Let's consider. Now now what we'll do actually is like we'll try to use some ingestion tool. What does this ingestion tool refers to? Ingestion tool is nothing but, guys, like more specifically, one second, you can see this notepad. See guys, actually we get the data from source. More specifically, you can consider MySQL. Now actually what we'll do is like, now the thing is like, as I already said that definitely there are multiple things will come into the picture as a data pipeline. Now what actually we'll do is like we'll try to use some scoop is a ingestion tool. Scoop is an ingestion tool. What actually it does is like it just import your data. Let's consider if your data is present on MySQL, it will transfer your data from MySQL to HDFS. It will just transfer your data from MySQL to HDFS. Now in our data pipeline, actually what we'll do is like more specifically, we'll transfer our data from MySQL to HDFS. We'll dump our data onto the HDFS. On HDFS, what actually we'll do in real time is like we'll try to do some like more specifically when we dump our data on MySQL, our data is like in raw format. Our data will be in present in raw format. And you also know that when we are getting the data, definitely data is not that clean. Data might consist of negative values. Data might consist of some unknown null values. Many things are included. So what actually we'll do is like on these HDFS systems, we'll try to perform some cleaning activities. Whatever the data present in HDFS, we'll try to perform some cleaning activities. For cleaning activities, we either use we mostly try to use Hive or else try to use Pig. These are the both text technologies which actually like you can consider. Pig is a scripting tool and Hive is a data warehouse. So many people use Hive or Pig, and will try to remove all those what are the nulls present in that text tag, like HDFS. In HDFS, whatever the nulls are present, whatever the unclean data is present, we'll try to remove that. And what finally we'll do is like after this we'll try to we'll try to we'll save it at somewhere. Actually, like consider you will say when we are applying Hive, we'll definitely store it at some location. Let's consider some location we have said. Now based on the customer requirement, what you will do is like you will try to write this Spark logic. More specifically, you can consider that you will write some transformation logic. Here transformation logic is nothing but you just don't confuse. Like transformation logic is nothing but consider, let's consider if you're having some 1 2 3 4 5 6 7 8 9 10 these numbers. Let's consider you have, if someone asks you to get the normally some, consider if someone asked you to get some logic, let's consider he wants some odd number, then what you will write? Definitely number divided by 2, and if it is equal to 1, then you say that it is a odd number, and you will try to print out that. Such kind of logics only you will write here in transformation. But here the logics, whatever you will write, you will write it in Spark. You will write it in Spark more specifically. Spark. Spark. You will write it in Spark more specific. Now, as you are applying some transformations, you are transforming your data. You are transforming your data according to the customer requirement, according to the requirements. So you are transforming your data. That's the reason we call this layer as more specifically transformation layer. Transformation layer. You can consider transformation layer. So now actually what happens? Transformation layer is done. So now let's consider after transformation of data, you got some 40 rows of output. Let's consider. So now what we'll do is like instead of directly sending our data, directly sending our data onto the destination layer. What we'll do is like we'll try to add one staging layer in between. We'll try to add some staging layer in between, and after staging, what does this staging layer refer to? What actually the staging is? Don't confuse. Staging is nothing. Actually, in real time, what actually happens is like when we are transferring our data from one layer to other layer, what actually happens is like, let's consider now after transformation you got 40 rows of output. When you are transferring your data from one layer to other layer, what actually happens is like sometimes you will miss some rows, you will might miss. Let's consider one row you might miss, two rows you might miss. So now here it is just a checking layer. What we are doing is like we are just transferring this 40 rows of data to here, and we are just checking that whether we got 40 rows of output or not. If we got a confirmation that 40 rows of output actually got from transformation layer, and now when you are shifting it to staging layer, we got 40 rows of output, then when we got confirmation, then we'll transfer our data directly to the destination layer. So in destination layer, we'll store our data in table format, either in Hive or in HBase, or else we'll try to save our data in HDFS. These are three options. So when we store our data in Hive or HBase, Hive/HBase, so let's consider, you know that definitely whatever the data will be building this data pipeline, and we're directly finally storing our data onto some table format. So definitely you know that Power BI and Tableau developers will pick this data and will try to build some good dashboards. So when you are storing your data in final destination layer, if you store your data in table format only, then only this Power BI and Tableau people will able to connect your data. If you don't store your data in table format, then it's highly impossible to get connected with that data more specifically. So this is actually, so in that context only, well, if our let's consider you are storing your data in for destination. No, at that moment you have two options. If let's consider if your data is being used for building dashboards, then try to save your data in Hive/HBase. Let's consider sometimes we'll transform our data, but because of that data is not being used for building some dashboards more specifically. In that context, you can store your data on HDFS more specifically. So this is what actually the thing is. This is a, you can consider this is a procedure. So the procedure only we actually called as data pipeline more specifically. In this also, guys, I will tell you one thing more specifically. Here I said source, we are from source, in source, from source we are getting data, we are doing something, and finally we are storing it at somewhere, we are storing it at some destination layer, finally we are storing it somewhere. So now guys, 1 second. Now now this source will actually will this whole thing, whatever I have explained above, this whole thing we don't consider it as pipeline. What actually the pipeline is, actually the source from where actually we are getting, we call that as producer, we particularly call it as producer. And where actually you are storing finally, that will call as consumer. And what are the activities you are doing in between, what are the activities you are doing, something you are doing, right? You are doing some high, you are cleaning the data, and finally you are cleaning the data, you are storing the data, you are cleaning the data, you are applying some transformations on that, and you are creating, you are doing some staging kind of activities. Whatever the things you are doing in between this source and destination, those all these things will called as data pipeline more specifically, you can consider. This will call as data pipeline. This is what actually the data pipeline is. So this is what actually the data pipeline, and this is what the generic architecture when you are working as a data engineer. If you want to get into the data engineering, or if you are working as a data engineer, whatever it might, the company it might be, the the whatever this generic architecture will be generic. There might be some add-ons or subtractons which you might be using, like you might be using Spark in place of Hive, you might be using Pig in place of Hive. So these kind of things actually you might come across. So now guys, when it comes to we'll try to understand big data tools. We'll try to understand what actually big data tools are. So big data tools, guys, so in big data there are multiple tools. So if we go with Hadoop distributed storage, if we go with the distributed storage, guys, distributed storage, we have a service called HDFS, which is nothing but, which stands for Hadoop Distributed File System. It is a service which actually stores your data. This is one of the big data. And you can another service is more specifically ingestion tools. Ingestion tool. Ingestion tools. What does this ingestion tool will? Ingestion tools are nothing but it will just transfer your data from MySQL to HDFS. So what are the ingestion tools? Actually, Scoop is one of the ingestion tool, and Nifi is one of the ingestion tool. Scoop and Nifi. So these are the most specifically being used tools. And after that, when it comes to data warehouse, what actually the data warehouse? Data warehouse is nothing but, let's consider, that transactional systems and analytical systems. So data warehouse is nothing but, when you let's consider if you want to store your data on huge format, uh, let's consider your SQL only. In SQL, there is some limitation. You can't store a higher amount of data. You can't store some history of data. History of data you can't store. Let's consider 10 years data, 15 years data, 20 years of data. You can't store it. Can't store it on SQL. Even if let's consider some 6 months of data, if SQL is capable of storing also, when you are processing it, when you are querying it, like on that particular big data, that kind of big data, what actually happens is sometimes your system might crash, and the query performance is very low actually. So in that context, what actually this data warehouse will come into the picture, and it will resolve our problem. What actually data warehouse is nothing but, it has a capability of storing huge amount of data, history of data. It can store history of data. and on that history of data you can perform analytics, you can perform Hive HQL queries. It's a HQL is nothing but more specifically, it's more specifically exactly you can consider it is more equivalent to SQL only, more equivalent, not totally, but it's more equivalent to SQL only. And you can just what data warehouse, what actually we'll do is like we'll try to store our data, and we'll try to based on our requirement, we'll try to perform some queries. Let's consider simple queries. Let's consider you do some aggregation queries, you do some count, if you want to count what the count kind of thing queries you will write, right? Exactly kind of things you will write in this HQL more specifically. So when it comes to data warehouse, there are two data warehouses more specifically. Hive is one of the data warehouse, and there is one more data warehouse, Teradata. And nowadays there is one more data warehouse which is nothing but Snowflake. It is on cloud. This is very famous nowadays, like Cloudera, like Snowflake is becoming so famous. And when it comes to computation services, guys, when it comes to when you come to computation tools or computation tools more specifically, we have two computation tools. One is MapReduce, and another is MapReduce, another is Spark. So MapReduce has some limitations due to which actually Spark has been evolved actually. So actually what happens is like in MapReduce, when you are storing your data on MapReduce, it will store your data on hard disk. It will store your data in hard disk. So what happens is like, let's consider if you want to read, something. Now what it will do is like when you are reading, it will hit the disk, it will hit the disk and get the data. It will for very first time it will hit the disk and will get the data. After getting data, if you after performing, it will again go, it will store your data in disk only. It means for one operations, two disk IO is happening, two disk input output are happening. You can understand that for at least one thing, two operations are performing. It is not that performant, and it will take a lot of time. When it comes to Spark, Spark, in Spark what actually happens is like whatever the data will get, right, that actually the transformation kind of things, everything, the data which actually will store, that will all processing will happen in memory. In memory it will happen. And you final see when you are reading the data, it will get stored in memory. It will get stored in memory. And when you are performing something also, after getting result also, it will store in memory. And let's consider you are getting some first output, and after you are getting second output, and you got third output. It will wait until last output comes. Once it confirms that now another in you will be not performing any transformation further. At that moment only it will go and store your data in a hard disk. Till that moment everything will happen on memory only, in memory only, due to which actually Spark is very performant. You can consider that like Spark is 100 times faster than MapReduce. So this is what actually whole thing in regards to like big data more specifically. So here I have said that there is a distributed service, distributed storage, right? You can consider that, you can see here, this is a distributed storage where actually we'll store our data. And after distributed storage, I said that there is a Hive data warehouse. It just do some kind of cleaning kind of activities. So we like here Hive or Pig will use and will do some cleaning kind of activities. After that, Spark is nothing but is a computation engine. Here you can literally see, and it will do some computation kind of activities. It's nothing but transformation kind of things. And after that you can see that see big data ingestion tools. Here you can see I have said that we are using Scoop is nothing but here it is just transferring your data from MySQL to HDFS. Here we are using Scoop kind of ingestion tools. So overall if you consider the architecture of this real you can consider this generic architecture. There will be some source layer, there will be some ingestion layer, there will be some storage layer which is HDFS, there should be some data cleaning layer, there will be some transformation layer, there will be some staging layer, and there will be a final destination layer. So this is what actually like more regards to big data in terms of big data. So this is what actually the generic architecture, and these are the things, these are the tools and technologies which actually we use in real-time scenarios when it comes to like currently we are using when you go with real-time scenarios, you might see these kind of technology you will be using as a big data developer. And apart from that, you might also use cloud services. I'm not saying that you are not using, you might not use cloud services, but the thing is, like, if you know these on-prem kind of things very perfectly, or very, if you know the things in very deep manner, if you know internals in a very deep manner, then cloud is nothing. It's not, it doesn't take that much time to understand the things more specifically. So this is what actually whole things regarding big data. If anyone is having any doubt in terms of big data, can picks up questions as well. Anyone is having any doubt, guys? Guys, try to send the answers like questions on chat, because I'm not able to hear. Don't know, due to some issues, it might be my audio might be I might be audible to you, but you guys are not audible to me. So let it be. So if you are having any questions, you can text it. I'm just seeing the text. I will try to answer that. No doubt. Okay, cool. Uh, Thank you, guys. Thank you.
Thank you, Karthik. Thank you, Karthik, for your wonderful session. Is there any questions from participants' side? You can go ahead now. Okay. I hope everyone have a valuable time with Karthik. For downloading the certificate, I already shared the details in the chat. So you can, once you go into that link, you need to enter the code 31COVM. Then you can download the certificate. Once again, thanks to all of you. Have a great weekend.
Thanks, everyone. Have a great day ahead. Good night.